Okay, Assalamu alaikum. This is engineering design, chapter 4, and this will be the final chapter for your final exam. We have already 5 chapters, but there is no time for that. So, chapter 1, 2, 3, 4 will be for your examination. Okay, and this is design analysis. The chapter name is design analysis. What chapters we finished? Chapter 1 was the finding a problem. Chapter 2 was the goals and specifications. Chapter 3 was abstraction and modeling, right? Chapter 4, design analysis. Okay, let's study about this chapter. So, methods of design analysis. What are the methods we have? We have some methods. Evaluating alternative designs. We have to check for the what are the different alternatives in the designs available and what we can think about the alternative designs. Next, rank ordering the design goals. We have to make some ranks for the specific goals. Means we have to already study about the specifications and goals of particular problem. So we have to order those goals in the rank wise. First goal, what is the rank? Second goal, what is the rank? Then we have to rearrange it. As per the rank, we have to rearrange the goals. First, we have which one we have to finish. Second, which one we have to finish, like that. Next, assign weighting factors to the design goals. After ranks is finished, you have to put the weighting factors, how much weightage it occupies, how much powerful that goal is, that we have to assign. We'll study one by one. Next, rating the alternative designs. Whatever we studied, we have to study about the rank ordering, the design goals, and assigning the weighting factors to the design goals is for a specific goal. Now we have to think of the alternative designs and alternative goals and specifications also. So rating the alternative designs, that is, we'll study. Next, we have to, by getting all the information of the point number 2, 3 and 4, that is design goal, ranking order, assigning weighting factors and alternative designs, combinedly we will create a decision matrix, which one has to be followed. This is called decision. We have to take the decision. Next, economic analysis. After the decision matrix is ready, means which solution you are taking into picture. Once it's ready by decision matrix, then we have to start about the economic analysis. Means how to spend the money, where to spend the money, where to get the money. That one, economic analysis. Is it going to achieve all the goals, all the specifications by spending the money or not? We have to find the in economic analysis. So in the economic analysis, we'll study about the what is the cost of that problem solution, how the returns will be there on our investment. Next, what is the time value money? Means we are spending so much of time and we are spending so much of money on that. So we will get the returns or not. So we have to calculate that one, time value money. After 5 years, what is the value of that money what we are spending? So that we have to study. So one by one we will study. So what we are going to do, all these 6 items we will study in this class. So rank ordering. It is a critical that one first rank order the design goals, since any subsequent evaluation and comparison of alternative solution will be very dependent upon the priorities given to each of these goals. Means we have to order the goals in some ranks, first rank, second rank, which is not important, which is important, that is telling. Example, some example is there so that you will understand easily. Cross, some name is there, in 1989 of rank ordering design goals is shown in table, which lists some of the goals to be achieved by a new computer system. In 1989 means some computer was evolved, some design was taken place, but they are checking the goals. What are the goals we have? Performance, minimum maintenance, aesthetics, minimum cost, availability of parts, ease of use, versatility and probability. So these are the goals we defined for creating a new computer, the computer desktop, the computer system. So these are the goals already defined in chapter number 2 what we studied. What are the goals? So on these goals we are now giving ranks. See chart. See here very important is left side we put all the goals. On the top side also we put on the goals. Now we will find the rank based upon that. Rank C, performance. To the performance, there is no rank for that. with the performance to the minimum maintenance, which is more powerful? Minimum maintenance should be taken place or not? Like this example, the scores in the given row for each goal are then summed and the goals are listed in the final rank order according to their total score. One now has relative rank order of the goals. The next step is to assign absolute weighting factor. Okay, so now we'll study how this is happening. So we have three steps in the rank ordering. If you feel that performance is more than the minimum maintenance, then you have to give 1. If performance and some other goal is both are equal importance, you have to give 0.5. The rank, how the rank is given. Only 3 points are there here. The same goal means one goal with other goal is overcoming, means this is more important than this one, then you have to give 1. If this goal and this goal tie up, no, both are important, then give 0.5, 0.5. Okay. If the goal is better than the shown goal, then 1. If the goal is nothing than the shown, then 0. For example, performance should be overcome with the minimum maintenance, means performance lazim good, so 1 we give. Performance based upon aesthetic means looks, how it look like, the shape, look, so how it is, no, performance should be win, performance should be the strong. Next, cost, no, performance and cost both are balanced, right? Both should be balanced one, means both should be important, so 0.5 nus. Next, performance with the availability of parts, no, may not be parts, may not available, no problem, but performance should be the important or parts are important? Parts are important. If parts are not available in the market, then repair will be the problem. So that's why it is, no, it is 1, because performance is more important. Now, performance compared to ease of use, means minimum maintenance, means how it is easy to use. So performance is very important. Now, performance coming to the versatility, means how strong it is, right? So performance is more important or versatility is important? Versatility is important, so it's 0. Performance with portability, at that time portability is more important, right? Small shape, portability means it should carry everywhere, so performance is least 1, so it is 0. Next, minimum maintenance, same, minimum maintenance with performance, or we can check like this also. Same, the row will come in the vertical also, column. See, performance dash with performance, minimum maintenance 1, aesthetics 1, cost half, availability of parts 1, ease of use 1, versatility 1, portability 0. Same will come here in the vertical. Check, minimum maintenance with the performance 0, because it was 1. Now aesthetic with the performance, previous it is 0, because it is 1 with the performance, means opposite will come. Whatever the row will be there, the column will become reverse. Row with performance dash, with minimum maintenance 1, but with minimum maintenance with the performance it was 1, here it is 0. Aesthetic with the performance, what is there? Performance with aesthetic 1. Now aesthetic with the performance 0. Cost with the performance nus, because it's nus, so it will become nus. So opposite will come. What is the row? The column will become opposite. If nus is there, same will be there. The 1 becomes 0, 0 become 1. Means the importance, the ranking order. Now, once you get that all the details, then you have to sum up for the total. 1 plus 1, half plus 1 plus 1, 4.5. Next, second one, for minimum maintenance, we got the weighting factor 1. Aesthetic, looks, we got 0. Means at that time, looks is not important. Nowadays, sleek model, that should be good looking, should be there. Now it is there. But in 1989, computer should work fast. Computer should have many features. Computer should be very fast, and cost should be less. Like that was there, not for the looks. Because old computers were big and bulky, right? Now, best computers are there. So cost is which one? Aesthetic, looks is 0. Now cost become 4.5. Availability of parts 2. Ease of use 3. Versatility 7. What is versatility? Ruggedness. More parallel operation should be done. Versatility. Portability 6. Now, based upon this, now you tell me which is have more weightage. Which have more weightage? Total 7 means versatility. The computer do more operation at a time and should be strong. Versatility for many operations at a time. Versatility we call. Okay. So first rank that one. Next 6. What is that? Portability means its size. It should carry everywhere. Portabilities. Next we got 6, 7, 4.5, 4.5. What are there? Performance and cost. It coming into the third cadre, third and fourth cadre. Performance and cadre. Next we got 3. That is ease of use. Okay, easy to use. Easy to use. Next we got availability of parts. So like this rank orders are there. So final rank order design goals for a computer. What is that? First I told you 7 versatility. Second portability 6. Performance and cost is high. Means both are same. Is to use. How to we are using. Next availability of parts, minimum maintenance and aesthetics. So like this we are giving a ranks to goals which has to be fulfilled much strongly. That one. Next we study the second point. Assigning weighting factors. Now we got ranks. Now we have to assign weighting factors to the goal. Each design goal, one approach is simply to place each goal somewhere along an absolute scale after discussing the relative importance of the goals with all members of the design team and other people such as customers, management and marketing. So here we are giving weighting factors by a committee meeting. Board of directors, engineers, meetings we have to place. And another one is feedback from the customer. We have to ask the customer what exactly they need in this product, in this system. Then we have to assign a weighting factor. See how the weighting factor is there. In order to accomplish this task, one should decide upon the range of values from 1 to 100. You have to give the rating factor 10%, 20%, 100%, like that. That will be used for weighting factors. 1 to 100 you have to give. Now separate the range into general categories of significance as shown in table. In this table we have defined the range 71 to 100 for weighting factors as judged critical for success. Means if the weighting factor is more than 70, then your product is that goals are very, very important and you will get the success in that. Means you will get the more benefits from that. And that is reserved for those goals which must be achieved if a design is to represent a valid solution to the problem. See here. 1 to 30 optional. We may not include or we may not consider for that one. And 31 to 70 important. We must give some important for those goals. And 71 to 100 critical. They must be accomplished. They must to be taken care of it. Next, important. Next, optional. Like your car. When you are designing a car, what are the main importance in that car? Engine, mileage, transmission. What are the important one? Safety. Inside what we call the airbags, safety airbags, braking system. These are important one. What is optional one? Color. Next. Comfort. Another one. How it look like. Inside accessories like music system, deck system. These are the accessories, right? These are optional. So based upon the market need, we can change this one. So that's called weighting factor. Next. Assigning weighting factors to design goal. Continuation. Each design goal, one approach is simply to place enough goals somewhere along an absolute scale after discussing. Okay, this is finished, I think. Yeah. That's why I'm repeating. Okay, now. Next one. Okay, continuation. Okay, then what we have to do? The engineering design team should then evaluate each goal, beginning with the most important goals. The team should try to assign a weighting factor to this goal that will accurately reflect each team member assessment. See, the same one, computer one we are using now. The computer, what is the first rating we gave? Versatility, right? So where we keep that one? Here, 100%. Next we got portability, right? We got it. Next we got cost and performance both. See, cost and performance both we put in the 80. So this become a critical one. Means this has to be accomplished. Next is of use. Next we got availability of parts, minimum maintenance. This we put important. Means we have to take care of that. Not the most important, must, but it should be important. Next, aesthetics. What is aesthetics? I told looks. So not important that one. It should not be that much good in shape or good in looking. No problem. That is optional. Last option that one. So like this, we have to keep the goals inside these weighting factors. 0 to 100 is the weighting factor. 0, half and 1 is we give some ratings. This is 0, half and 1. This is the rating. Okay. Next, weighting. Weighting factor is 0 to 100. Another one now. Last one. Assigning weighting factors, design goals. Yeah. Rating the alternative designs. Next, one needs to rate the relative success or failure of each design alternative in its ability to achieve each goal. Rating or utility factors are assigned to each design as follows. Some utility factors now. If possible, use the measurable parameters to estimate the success or failure of each design in achieving particular goal. How? For those goals that cannot be converted into a truly quantifiable form, an arbitrary rating scale such as that shown in table can be used, for example. Now we know that weighting factor is 0 to 100, right? Now we have to go for the alternative design for each goal. Okay. See, now alternative design, we put a design rating factor. For each goal, we are putting a design rating factor with 0 to 10, the scale. Failure, unacceptable, mediocre, satisfactory, good, excellent. Means we got some 10 number of goals for each solution. Then we have many solutions, and we call it alternative solution. We should not go for with one solution. We should not start the design or start the what we call manufacturing with one solution. We must have many solution that we call alternative solution. So for first solution, we got rating factor, weighting factor, right? On those goals, 10 goals, what example I'm telling. Now for another alternative design, another goals will be there. Maybe 10 or 15 goals will be there. Okay. Those also got rating factor, weighting factor. Then another alternate design got another some X goals. Those also got rating factor and weighting factor. For example, 3 we have now. Now in these 3, each goal should be given these design rating factors. Is that goal is failure or acceptable or good or excellent? That we have to give. We'll see that one how. So now decision matrix. Among these all, we get the decision matrix. See here. The weighting factors for the design goals together with rating factors means Jamahada. Together with rating factors for each alternative concept are then inserted means mixed within a decision matrix as shown in the table. Each weighting factor is multiplied by the corresponding rating factor for each design. Means we have to multiply. Zerb, right? Multiply means Zerb. Yeah, we have to Zerb now. Previously it was only just identification, how much, and summation was there. For rating factor, what we got? Sum. 0, 1, half. We are adding all this one. But now we have to multiply. How it look like? This is called DF equal to weighting factor multiplied by rating factor. These two we have to multiply. So this is decision matrix we will get. What is DF? So this already studied. Now check. The decision factors are then summed for each design and stored in the right column of the matrix. In the table, we see XKZ model. So another example they are giving. 10 design alternatives received. No, I only speak about 3 design alternatives, but XKZ model has 10 design alternatives and each design alternatives got some goals. So that we are explaining. Example. Okay, a total score of 3640 they got it. Outpinning other than 3 design. Okay, if 2 or more designs have total decision factor scores that are within 10% of one another, the result should be interpreted as tie. If it is within the 10%, we'll explain in the table, no problem, you'll get confused, I know. Then we will make a tie. If more than 10%, we have to take it. The design should be then compared on a goal by goal basis, focusing upon the individual ratings achieved by each design on the important goals. See here. Now you can understand here. Now design alternatives of this model XKZ model 10. Port tech something, logic pack, some name is there. Now what are the goals we have? Versatility, right? Portability, performance, cost, ease of use, availability of parts, minimum maintenance, and aesthetics, which is the last one. Same example is going on. And what is the weighting factors? 0 to 100 we put it, right? 0 to 100 we put it. 0 to how much? 50. What we have? 0 to 50 we have. No, critical. What is the critical? 70 to 100 is critical. Important. 31 to 70 is important. 0 to 30 is optional, right? Same thing we put here. 0 to 15, 40, 45, 60, 80, 80, 95 and 100. We kept it. Now where from these numbers are coming? 7, 6, 8, 7, 7, 9, 6, 9. Where these numbers are coming? These are coming from the weighting factor. How much this one? So versatility, how much we got? 7, right? Okay. This 7, 6, 8, 7, 7, 9, 6, 9. From where we are getting? From the rating, first one, first option, rating factor. We gave some rating and we jama all this one. So that we are getting. Versatility, how much we got at that point? 7. Right? So this is one alternative. 7 we got. Second alternative we got 4. Another alternative we got 6. Another alternative 9 they give. These are different alternative solutions. The values are there. It doesn't mean that only one we taken. Alternatives of different alternatives. Now portability, we got 6 in first example, right? In the first sheet, 6 we got. How much for the next one? 3, 7, 6. Like this, different we got. We have to write it here. Now 7 multiplied by 100, 700. 6 into 95, 570. 8 into 80%, that is 640. This is multiply. 7 into 80, 560. 7 into 60, 420. 9 into 45, 405. 6 into 40, 240. 15 into 9, which is aesthetic, very less important. We gave 9 rating, but what is the aesthetic value? Very small. So it is 15% only. So 135. So now sum it. Total you have to sum this one. For 700, 570, 640, 560, 420, 405, 240, 135. 3640 we got it. Okay. Now with another alternative design, same procedure, we got this one. 400, 285, 480, 480, 420, 360, 360, 60. 2845. Okay. Another alternative design, we got 3370. Another alternative design, we got total 3100. So which is the best one now? The first one. Which got best score for decision matrix? The first one, 3640. From where we are getting? From the first example, right? Where we give the percentages. So these are the different alternatives and we get the final decision matrix like this with different alternatives. Okay. So this is how we go for the decision. Then what is telling? Now decision factor is equal to how much? Weighting factor multiplied by rating factor. So this is the decision factor. 700, 570, 860. This is nothing but your decision factor. Now, last one, economic analysis. Once decision is made, which alternative design we have to take, and with in that alternative design, which type of weightings and ratings of goals we have to collect, we got it. Okay, like performance, first one, aesthetics, last one, right? We got it. Now we have to find out what is the economic analysis, how much we have to spend, how much returns we are expecting. If today, if we are spending after some years, what is the value of the money, that we have to find out. Then our design is ready. Last topic, economic analysis. In this, we have three parts. First one, cost estimation. What is it? Cost associated with the design and development of a new device, system, or process must be carefully estimated. So, the design may be of your device or system or process. This we are studying from the chapter 1. Okay, our design may not only for object, maybe a system, it may be a process, it may be a device, right? So, we have to be careful for cost estimation or cost calculation. So, such cost may include, what are the cost? It may including construction, already you know, of a new manufacturing, environmental impacts statement, cost it includes, because environmental impact statement, like your thermal power station, we are when we are generating the fumes coming out from the power station, we have many gases, much more ash will be there, it will disturb all the environmental. So we have to put a chimney, we have to put a filters, like your car exhaust system, we put some filters, so it should not come out the black gas, or it should not come out some diesel or petrol, it should not come out. So that's why we have filters in the exhaust. Like this, environmental impacts statement, how much cost you are spending. Depreciation of a capital equipment, that is the money that will be necessary to replace worn or discarded equipment. So depreciation means once you use some device or some part of the device, when we are selling it back, then how much money you will get. That's called depreciation. Means from actual amount, how much the amount is reducing when you are selling back. Like your car, once you purchase the car, after 5 years you will sell it. Same amount you are getting? No, right? You have to sell for small, less amount. So what is the depreciation? The minus of these two is called depreciation. Okay, taxes, how much taxes we are paying to the government. Materials, how much you are purchasing. Some may be usable, some may be reusable, some may be thrown out. These are materials. Direct labor, labor means here the workers, labor who work for the designing. Packaging, you have to pack that equipment. Distribution, to sell, you have to distribute to the different regions, different countries. And transportation expenses. Marketing means, marketing is a big challenge nowadays, because you design a good product, but if it is not marketing is done properly, it will not sell. You have to say something about that product, that this my product has so much features, so many things it can accomplish. We have to compare with other models. So that's called marketing. Repair, sometime in future repairs will come. Scrap losses means once you design one product, some items will left over. That's called scrap. We have to throw it. So when you sell that one, how much amount you will get? That also we have to check. So this is one. Another one, overhead cost. Cost not directly related to the development, manufacturing, and marketing of a particular product, such as supplies, maintenance, indirect labor, security, legal representation, and rent. Because when we are designing some product, we must take a house or take some land, right? You have to specify some land for it. Then the rent will be there. So many costs will be there. Legal representative means you have to put some lawyers. You have to pay something to register the case or to register the device for registration process, and we have to pay for the security so that the item should not be theft. Okay, and indirect labor. Sometimes daily wages labor will come and they will take the money and go. That's called indirect labor. Okay, maintenance options will be there. Different supplies we have to put. Next, finally, one need to be able to estimate the profit that could be generated by a product based upon its expected selling price and sales volume. So, what is the profit? We have to check now. So, these are the cost estimations. Three steps are there. One is direct, one is indirect, one is final profit. These three are there. Next, continuation. The second part, return on investment. How much you are getting return on very basic estimate of the economic viability of a design is the return on investment, ROI we call return on investment, that it can be expected to generate. Means when you are spending so much of efforts or money, time, design big people, then how much you are getting returns on that. That's important here. So return of investment is simply the percentage of the initial investment that will be generated as a profit if the design is implemented. Means how much you invested, then how much you sell, what is the balance. That is your return of investment. Companies have a broad range of investment opportunities for their funds. The expected ROI for a design must be competitive with other available investment alternatives. If the design is to be funded, means we are not so much rich. We may have good idea of that product. We got so much procedures, making our design alternatives, making good goals, making good specifications, but we must get money, right? Who will give the money? Bankers. Some other loan, we'll take the loan. Then when they are giving loan, maybe bankers or some other person, what they will think in mind? In so many years, how much they will get return, that they will see. Then only they will give the money, right? So the companies have a broad range of investment opportunities for their funds. The expected ROI, that is return of investment for a design, must be competitive. Means they are not giving for us only, they are giving other companies also some amount. Means they will see the competitiveness. Means how much return is coming for nearly same product he is also designing. How much investment we are making, how much return he is getting. And if I give to you how much return you are getting. So you must quote a competitive value that you will get this much return. My product is very good. Like that you have to mention. Then only they will give money. They will fund you. Fund you means they will give the money. For example, consider this. Consider a situation in which return of investment for a design project must equal 15% or more for the project to be approved for funding. If it is more than the 15% only, the banker will give fund. Then only you can go ahead for your project or for your new solution of the problem. Otherwise, they will cancel. Your project is abandoned. It will not be there. See here. If the initial investment for the proposed design is estimated to be $300,000, let us take initial investment what they thought, and the expected profit on the investment is $36,000. Okay, profit means here only profit, not the exact how much spend money. No, profit what we are getting once you sell it. Okay, so profit is $36,000. Initial investment is $300,000, but profit is 36,000. Then the ROE is the return of investment is simply the ratio of the expected profit to the initial investment. So open the calculator. See the what is the value? Return on investment is the ratio of expected profit to the initial investment. 36 divided by 300. How much is the value? 36 divided by 300. Because 1,000 will go anyhow. So only ratio will be 36.12, right? 0.12 means into 100 means 12%. So what is the target? More than 15. Must be more than 15. Then only the project is approved. So how much it is getting now? 12%. Itnash, right? So it is less than 15. So what happens? This project abandoned. They will not be approved. The money will not come from the funders, means the bank people.
26,000.
Yeah. No. It's total. Complete profit means you design a mobile. Let us take. You will design only for 100 pieces or 1,000 pieces. You will not design this for lifetime. So like this, it will calculate. If I design a mobile for 100 pieces, now you are investing $300,000. Okay. Now when I sell this one, $300,000 plus $36,000, you will get the money. So what is the profit? 36,000, right? So that 36,000 divided by $300,000 is your ROI, return of investment. So what is the percentage? 12%. Your project is abandoned. They will not give the money. These things you have to calculate. Okay. Then what we have to do? Again, we have to calculate with from rating factor, decision factor, specifications, goals. Again, we have to see, and we have to increase our profit. Then only our ROI will percentage will increase more than 15. Then the project will be approved. See here. ROI. See how much is coming? 12%. Because this ROI is below minimum threshold of 15%, the project will not be approved for the funding and further development. So whatever the mind you put for the alternative design, for the calculation, everything is gone. Product is not ready. Only the paperwork is there. How much my goals are there? How much is the specifications of that one that we are studying? Okay, last topic. Time value money. Economic analysis. When performing a cost analysis of a design, one should begin by recognizing that money has a time value associated with it. A specific amount of money P, let us take we have P amount of money invested today at an annual interest rate I will be more valuable after n years. Now let us take 10 reals today you have. Okay. After maybe 1 year, 2 years, the 10 real value will be 10 real only? No, the value will be 15 reals, maybe 12 reals. Because day by day our cost of living is increasing. Cost of this one is increasing. All our groceries are increasing. So the value of money will increase day by day. So that we have to calculate. Now I am giving to manufacture something to you, investing something after some 5 years, 10 years. What is the value of my money at that time? Now, then we have to see the profit, how much you are getting. It is balancing or not. Otherwise, waste. That is called time value of money. After some time, what is the value of your investment? That we have to see. So, if P is invested annual interest, okay, will be okay. Will be more value and after year. Okay. In fact, the future worth of P is given by a simple formula. The future worth of P, that is F. What is the future value of the money is F, is equal to P multiplied by in brackets 1 plus Ni. Now calculate for 10 reals. 10 reals for a annual interest of, let us take 5%. 10% let us take 10% for after 5 years. What is the future value of your money? Easy, put it. What is N here? 10 years. What is I here? Interest. How much I told? 10%. Right? So 10% means 0.1. 10% how much? 0.1. How many years? 10 years. So 10 into 0.1. How much? 1. 1 plus 1. How much? 2. 2 plus the principal value. What is the principal value? 10 reals. No. What's the principal value? 10 reals I give. So 10 multiplied by 2. How much? 10 multiplied by 2. Zerb 2. Zerb. 20. So 10 years. Today the value is 10 reals. After 10 years, what is the value? 20. So this is your time value money. Means my 10 reals becoming 20 into the coming 10 years. Then when I give to you to spend somewhere and to give some profit, what we have to think? After 10 years, its value, my value is 20. Then you must give profit me more than that one. Then only I can invest on you. Right? If I give 10 reals, after 10 years, you give me back 10 reals, I will agree? No, I will not agree that one. After 10 years, the value is becoming more. So that's called time value money. Another formula is there. However, if the interest is compound over the n years, that is, if the interest is allowed to be accurate on both the principal p value and the interest already earned, the formula become future value of money is equal to p multiplied by 1 plus I whole power n. This formula will give the more accurate value of your future. Put the same thing in. Put the same thing. 10 reals is the principal value. 1 plus I is 10%. 0.1. 10% means 0.1. So 1 plus 0.1. How much? 1.1. How many years? 10 years, right? So 1.1 whole to the power 10. How much? 1.1 power 10. Huh? Yeah, yes. N is years. N. This N is years, number of years. 1.1 power 10. How much? See? We'll check in the calculator. Scientific calculator, where is it? Yes. No. Yeah, 1.1 power 10. 2.59. Check. Is it there? 2.59. So 2.59 multiplied by original our currency. How much? 10. So how much you are getting? 25.9 means 26 reals. This is called compound interest value. Means some bankers will follow this also. Some basic principles will follow the previous formula. F is equal to P into 1 plus Ni. Simple one. So that they want to give more benefit to the customer, means the manufacturer. Some is more powerful that I want more money. Then they will follow this formula. Okay, previously it was 20 reals after 10 years. Now this is becoming 26 reals after 10 years. So like this, we will calculate. Next example here, I am showing the example. Consider the proposed 5-year project that will require an initial investment of $3,000. $300,000. At the end of the 5-year period, the future worth of initial is investment with the expected compound annual interest 10% is directly 300,000 multiplied by 1.10 power 5. So now 300,000 becoming now 483,000. This is the calculation. Another. Okay. Thus, when estimating the funds needed to support a project, one must consider the time period during which the investment will be made and the impact that this time will have on the value of the investment. We have to consider both things. The difference between all the present worth of future worth of money must be taken into account when one evaluates the cost for successfully developing a marketing design. This is a part of banker, means who will give the money to you. That's one. So you have to be taken care. So this is about